Hi, my name is Quinn. I'm a math professor at Broward College. In this video, we will discuss mortgage amortization schedules. The process of paying down a mortgage loan through regular monthly payments is called amortizing the loan. Lenders create amortization schedules which include the monthly payments toward interest and principal, as well as the monthly principal balance for the life of the loan. Let's construct the first 2 months of an amortization schedule for a $320,000 loan at 6% annual interest for 30 years. One piece of information that we must have is the regular monthly payment required to pay off the loan in 30 years. We can use either a regular monthly payment formula or a table like this one, with monthly payments to repay principal and interest on a $1,000 mortgage. The value that's in both the 6% row and the 30-year column is the amount we need to pay per month on each $1,000 of mortgage. In this case, $5.99551. Next, we figure out how many $1,000 mortgages are equivalent to $320,000. In other words, $320,000 divided by 1,000, which is 320. We multiply that by 5.99551, and we see that our regular monthly payment must be $1,918.56. Here are the first 2 months' entries in the amortization schedule. Initially, we have a balance of principal of $320,000. We're going to begin to fill in the cells, starting with the interest for the first month. The way to calculate the interest payment is to multiply the balance times the annual interest rate times 1/12, because a month is 1/12 of a year. Here we've multiplied $320,000 times 0.06, which gives us $19,200. 1/12 of that is $1,600. That's our first interest payment, but we also need to make a payment towards the principal. We know that our monthly payment is going to total $1,918.56. To find out how much we're paying towards principal, we need to subtract the amount we're paying in interest, which was $1,600. And that leaves $318.56 towards principal. This is the amount that our principal balance will be reduced for the first month. So subtracting $320,000 minus $318.56 gives us our new balance of $319,681.44. We'll repeat this process for the second month. First, we calculate the interest that's going to be paid. The balance from the first month was $319,681.44. Multiplying this by 0.06, we have $19,180.89. 1/12 of that is $1,598.41. To determine how much is paid to principal, we subtract this amount from the monthly payment. The monthly payment is $1,918.56. Subtracting $1,598.41, we have $320.15 of the monthly payment that will be going toward the principal. That's the amount that the principal will be reduced. To find the new balance, we subtract the principal balance from the first month minus the $320.15 payment to principal from the second month. This leaves $319,361.29. As we prepared the amortization schedule, we repeated 3 steps over and over again. Step 1, find the interest for the month by multiplying the old balance of principal times the annual interest rate in decimal form times 1/12 of a year. Step 2, we calculated the payment on principal, which is the regular monthly payment minus the interest payment for the month. Step 3, we calculated the new balance of principal, which is the old balance of principal minus the payment toward principal. If we were to repeat this procedure 360 times, we would have the amortization schedule for a 30-year mortgage. Here we see examples of amortization schedules for 30-year, $60,000 mortgages at 2 different interest rates. We can't fit all 360 of the months on this table, so we have a sampling of the months for comparison purposes. Notice that in either case, the principal payment increases as the interest payment decreases. This is because the interest is based on the balance, and as the balance decreases, so does the interest. Since our regular monthly payment stays the same, the principal payment goes up. This also means that early on in the loan, you're not making much progress towards paying off the balance of the principal. Comparing these two amortization schedules side by side, we see a significant difference between the amount of interest paid on a loan with a 4.5% interest rate versus a loan with a 14.5% interest rate. In each case, the borrower is paying a significant amount of money. In the 4.5% amortization schedule, we see total interest payments of $49,444.03, which means the borrower is paying $109,444.03 for a $60,000 purchase. In the 14.5% interest amortization schedule, the borrower is paying $204,504.88 in interest for a total expenditure of $264,504.88. This means that the borrower on the right is paying $155,060.85 more in interest. Now it's your turn. Your challenge is to fill in the missing entries on the amortization schedule. Now the video will pause while you work out the solution. For best results, write your workout step by step on paper. When you're done, come back and select your answer. You chose option C. Let's check it out. First, we'll calculate the 23rd interest payment by multiplying the old balance of $153,377.68 times the interest, 0.045, times 1/12. This gives us $575.17. So far, so good. In order to calculate the principal payment, we need to know how much the total payment is. We can find that out by looking at the previous month's interest payment and principal payment. In the 22nd month, the borrower paid $576.34 towards interest and $312.99 towards principal. That adds up to a total payment of $889.33. That's the borrower's regular monthly payment. To find the 23rd principal payment, we need to subtract $889.33 minus $575.17. This leaves $314.16. You got it! Fantastic! As you continue to study, remember to use your resources. Read your ebook. Contact your professor when you need help. Ask your professor about tutoring on campus or online. Keep up the good work. You chose option B. Let's check it out. Notice that the 23rd interest payment should be smaller than $576.34, but larger than $573.99 because interest payments decrease over time. But $569.11 is less than both. This option is incorrect. Let's try another exercise. Here's a tip. Remember that to find the interest for the month, you can multiply the old balance of principal times the annual interest rate in decimal form times 1/12. And to find the payment on principal, we can subtract the regular monthly payment minus the interest for the month. You chose option A. Let's check it out. We can see from the 22nd month's entries that the total regular monthly payment is $576.34 plus $312.99, which is $889.33. Based on the proposed amortization in option A, the 23rd month would have a total regular monthly payment that's equal to the sum of $575.17 plus $313.12, which is $888.29. But the regular monthly payment should be the same each month. This option is incorrect. Let's try another exercise. Here's a tip. To calculate the interest for the month, you can multiply the old balance of principal from the previous month times the annual interest rate in decimal form times 1/12. And to calculate the payment on principal, you can subtract the regular monthly payment minus the interest for the month. Try this one. Your challenge is to fill in the missing entries on the amortization schedule. Now the video will pause while you work out the solution. For best results, write your work out step by step on paper. When you're done, come back and select your answer. You chose option A. Let's check it out. We can see from the amortization schedule entries for the 36th month that the monthly payment is $889.33. This means that the principal payment for the 37th month must be $889.33 minus the interest payment of $558.26, which is $332.31. So far, so good. To calculate the balance of the principal, we'll subtract the old balance from the 36th month, $148,870.53, minus the payment towards principal, $332.31. This gives us $148,539.46. You got it! Fantastic! As you continue to study, remember to use your resources. Read your ebook. Contact your professor when you need help. Ask your professor about tutoring on campus or online. Keep up the good work. You chose option C. Let's check it out. According to the amortization schedule for the 36th month, the total regular monthly payment would be $559.50 plus $329.83, which equals $889.33. On the proposed amortization schedule for option C, the payment would be $557.02 plus $331.16, which is $888, but the regular monthly payment should be the same every month. This option is incorrect. If you feel like you're struggling, that is part of the learning process. The important thing is to keep working and take advantage of all the resources available to you. Read your ebook in detail. After you read an example, try to work it yourself without looking at the solution. Contact your professor. Ask your professor about tutoring on campus or online. Then come back and try this item again. You chose option B. Let's check it out. The difference between the 36th and 37th proposed balance would be $148,870.53 minus $148,532.52, which is $338.01. This should be equal to the principal payment, but the proposed principal payment is $332.31. This option is incorrect. If you feel like you're struggling, that's part of the learning process. The important thing is to keep working and take advantage of all the resources available to you. Read your ebook in detail. After you read an example, try to work it yourself without looking at the solution. Contact your professor. Ask your professor about tutoring on campus or online. Then come back and try this item again.